So the last two problems you were supposed to do, that 62 and 64 from yesterday, were sort of giving you a taste of how trig is applied in different real-life contexts. So if you are an engineer, an architect, a surveyor, an interior designer, an FBI agent or some other special investigative agent, a pilot, a captain of a boat, all of these people rely on trig on a daily basis to do their jobs. So we're going to see trig applied in a couple different ways. But what we need to talk about first is how trig is measured. We know trig is measured in degrees, right? And so does anybody know, I think you should from geometry, how many degrees it takes to make a full rotation around around all four quadrants? 360, because every quadrant is worth how many degrees? 90, all right? So we have 360 degrees total in all four quadrants. And so if you told somebody to pinpoint, 57 degrees, I know you use protractors when you were in geometry, draw 57 degrees, draw 112 degrees, draw those different degrees. You can even be more specific. Think of it this way. I was born on October 17, okay? So that's the day I was born. But if I want to specify that, I was born in the 7th hour of the day, right? So you pinpoint it to the hour. And then if I want to be more specific, you pinpoint it to the what? To the minute. I don't know what minute of the day I was born at, okay? But you go from kind of something that's broader and you get it a little bit smaller. We do the same thing with degrees. Degrees, there's 360 all the way around. But if you want to pinpoint something smaller, you can go down to what's called a minute. Every degree has 60 minutes in it. So there are 60 minutes in each degree. Now, if I asked you to draw 1 degree, it would be very, very small. You would be hard pressed to draw 1 degree on paper. You'd be even harder to draw 1 minute of 1 degree, okay, but it gets you. It's almost like the Bible, right? Here's the book of the Bible, okay, now here's the chapter of the Bible, okay, now here's the verse in the chapter of the Bible. We can go even smaller, okay, we can go down to seconds. And there are 60 of those in every minute. All right, so the way we write that is if you want to specify the degree, you write it like this, 47 degrees. If you want to specify the minute, then you put 18 and you put a little hash mark, which means how many minutes you go beyond that. And then if you want to specify even to a smaller section, you would say 25 or something like that, and you'd put a little double hash, and that means seconds. So if you were going to add up and you wanted to have degrees that say added up to 90 degrees, all right, how many more degrees would it take to add to the one we currently have to get to a total of 90? Okay, so some people might say, oh, it's going to be 43 because 47 and 43 is 90. But is that true? I'd be over 90 degrees, wouldn't I? It'd be 90 degrees, plus I'd still have the 18 minutes and the 25 seconds. So that is not correct. So the actual number of degrees we need to add is actually 42 with some extra stuff added to it. So we got to think about, all right, well, how do we add? So how many minutes do we need to add to this so that we can round it up to a total of 90 altogether? How many more seconds do I need? Let's start with the seconds. I need 35 seconds, because that would give me a total of 60 seconds, which would give me a total of another minute. All right, how many more minutes do I need? Okay, 41 minutes. Because when I add this up, you're like going to be carrying everything, right? 25 plus 35 is technically 60, but it's 1, and you carry the 1, because that's 1 more minute. And then 1 plus 18 is 19 plus 41. That's 60 again. So carry the 1, because that's 1 more degree. And then 1 plus 47 is 48 plus 42. Now you're at 90 degrees, no minutes and no seconds. So you have to be able to add and subtract minutes and degrees from each other. So I'm going to show you how to do this on your calculator, which is why you need your calculators out. All right, make sure your calculator's in degree mode. Okay, so I just want to put officially in our notes that the notation is called DMS, okay, degrees, minutes, seconds. So we're going to use that to do some application problems where we're using trig to solve some different navigation things. Go. All right, a lighthouse is perched on a cliff. All right, positioned on the top of a cliff. A ship is spotted offshore. At 1,200 meters away with depression angle (6 degrees). How tall is the cliff? All right. So what we need to do from these word problems is to extract in our mind, in our imagination, a triangle. Okay, somehow the lighthouse, the cliff, the ship, they have to form some kind of a triangle, a right triangle, so that we can solve this. So in my mind, this is what I see. I see the cliff here with the lighthouse on it, okay? Not just using your imagination. Okay, then I picture the ship offshore out here, okay? And I can see the triangle is formed with the angle of depression. So the angle's coming from the, so I have a right triangle now created. So that sometimes your book will draw the right triangle for you and you'll have the picture. Other times you're going to have to create the picture on your own. We know that the ship is 1,200 meters away. And so that's going to be the base of my right triangle. We also have a 6 degrees, which is called a depression angle. So we haven't talked about that yet, so I need to teach you what depression angles are. We have learned alpha angles. Okay, alpha angles are those ones down in that lower corner. We have learned beta angles, okay, up in the upper corner. A depression angle is always outside that beta. The Greek letter is D. That's the Greek letter D. It's a delta. It's sort of like our D if you put a little hook on the end, kind of, but so that's the Greek letter delta. That is where depression angles go. Okay, a depression angle is different from alpha and beta. It's on the outside. Okay, so there, oops, is our depression. By the way, if they say elevation, if they tell you elevation angle, that's actually the same as alpha. So if you needed to know anything, that would be called elevation. But depression is outside of beta. It's different. It's on the outside. Okay, so we know our depression angle is 6 degrees. So I'll put a 6 right here. And that's going to help me actually come up with a value for beta. Because what's in beta has to be the rest of the degrees that would make a right angle right there, adding up to 90 degrees altogether. So how much would beta be worth?
84.
Beta would be worth 84. All right, so we're going to relabel that, and we'll have 84. So the depression angle and the beta angle should always add up to a total of 90 degrees. And we want to figure out how tall the cliff is, so I'm going to put X on the cliff, and I'm ready to go. I'm ready to figure this out. How is the X cliff side related to the 84? What's the relationship between those two? Adjacent. And how about the 1,200 on the bottom related to the 84?
Opposite.
Okay, so if I've got adjacent and opposite, what will I be using? This is a tangent situation. All right, because I have opposite here and I have adjacent next to my 84, this is an opportunity for me to use tangent beta is opposite over adjacent. So that's the formula I'm going to use. It's the tangent beta formula. So then I drop the numbers into the equation. So I'll have tangent of 84. The opposite was 1200. The adjacent was the x, and now we're back in business, and we're going to cross multiply and solve for x and get x alone. So when I drop a 1 and cross multiply, I'll have x multiplied by tan 84 degrees equals 1200. And then I'll divide both sides by that tangent so that I can have x by itself. So 1200 divided by the tangent of 84 degrees. And that will give us the height of the cliff. And then what units should go on there for measuring the height? Meters, because I was measuring 1200 for the offshore ship. Okay, go ahead and type that in. Tell me what you get. 100 and something. 126.125 meters. Bless you. Okay, any questions on that so far? Okay, ready to move on. All right, our second example. Okay, a special agent is tracking a car from atop a building that's 100 feet tall. All right, so a special agent is tracking a car from atop a building 100 feet tall. Okay, the car is first spotted at a depression angle of 44 degrees, 17 minutes. And the car is spotted again and the depression angle this time is 21 degrees, 34 minutes. How far did the car travel? How far did the car get? All right, so what we need to be able to do is imagine and picture what's going on here in terms of triangles. And there's actually going to be two. There's going to be a triangle for the first time you spot the car, and then a triangle for the second time you spot the car. And then we'll use those two triangles separately to help us get our answer. So in my mind, I picture my special agent in the 100-foot building. So here's my 100-foot building, and my special agent is up there, and he spots the car down below. Okay, and I'm not going to try and draw a car. We'll just say the car is here. Okay, so there's our car, and here's our guy up here keeping track of it. So he spots that. We know the building is 100. We don't know how far away the car is, so that's x. But we do know the depression value of the angle is 44 degrees, 17 minutes, which is going to go on the outside. So my job is to figure out what the beta value is on the inside so that I can have a beta angle to work with so I can do my trig. And remember, it's got to be something that would make a total of 90 degrees altogether. Okay, got it? Anybody got it? How many seconds do I need, or how many minutes do I need, and how many degrees do I need to come up with a total of 90? Well, let's first figure out how many seconds. Minutes, I keep saying the wrong thing. How many minutes I need. If I've got 17, how many more do I need? Okay, so I'm going to have 43 minutes. Okay, so that 43 minutes combined with the 17 minutes would give me a full degree. Plus the 44 degrees I already have. So how many total do I have now? Got 45, how many more do I need? Another 45. So this is 45, 43. If you are totally stumped and you cannot, are having a hard time figuring that out, you can use your calculator to help you. Pause this. Okay, 100 tan 45 degrees 43 minutes. 102.533. All right, any other questions? So you got 2 days to work on this. Okay, Wednesday, Thursday, I'll see you Friday, and we'll come back and see how you did on applying trig to some of those real life situations. Homework help is both days, so if you're working ahead and you want help already tomorrow, that's fine. And Friday I'll be available also before school.
Look on canvas. It's pages 7. No, you won't fail.
Let's see, Destiny.
Because good question. I'm low-key pumped. Low-key, I am. I just want to break. My knee, the back of my knee start. Boy, you want me to be injured the whole season? The grind starts next week.
Okay, wait a minute, we have time for a little bit of drum roll. Give me one on your desk.
What?
Okay, Destiny's going on board.
Ooh. I got this.
Yeah.
Shredding.
Do you want me to just do NWC or like actually write it down?
No.
Are people gonna know what that is?
We're about to.
I didn't even know that was.
Yeah, Destiny!
I have a peaceful rest of the year.
Joseph, you ready to go up there yet?
Not yet.
Can I change my answer?
You see Bert?
Nope, it's on the board, Gavin. It's official.
Can I change my name?
Wait, is Katie Wynn playing soccer at Oregon State?
Going for engineering.
Oh wow. Oregon State. No Beavers. Dude, the Pac-12 is amazing soccer. Why I think I'm like
Rachel,
near 70% towards Northwest.
did you end up ever buying a plane ticket? Okay. You still have the flight information I sent you?
Yes.
Okay, so look up that flight and see if they still have seats on it. And then if you decide you want to come, yeah, get your